Welcome everyone to an interesting DSA problem which is titled as Koko eating bananas. So this is a problem which is created using a bit imagination and all. Okay, I will try to describe what is the problem statement. So there is Koko, probably a monkey, who loves to eat bananas, and he should eat those bananas by following certain rules. So at some point, the guard on duty take a breaks. That is represented by this H. H is nothing but 8 hours. So the guard is on off duty for 8 hours. During this time period, the Koko is free to eat bananas, but he follows a certain rule. He can set his speed of eating bananas. Like he can choose to eat K bananas per hour. This parameter he can choose for himself. So he can eat one banana per hour or two banana per hour or anything. And he should he is following a certain rule that suppose if he eats 4 bananas per hour and he tried to eat one pile at a time, so what is going to happen? There is only 3 bananas on this particular pile. Since his speed is 4 bananas per hour, okay, he will have surplus time. So in the event of he is finishing one of the piles, even though he has surplus time, he won't go to the next pile. He will wait. Okay, so the surplus time is going to be wasted. But in other time, if his speed is something like 2 bananas per hour, in that case, if you look at the first pile, there are 3 bananas. So he would have already finished 2 banana out of it, and remaining 1 banana he will start eating. But in that case also he will have some surplus time, that would be some 30 minutes. So he is not going to use that 30 minutes to go forward and try to eat on the next pile. So this rule he keeps for himself. And one more thing is that he can choose his speed as he want. But what he likes to do is that he wants to choose the K such that he can eat it very slowly. No need to rush. So even though there is K is possible in a wide variety of way, as you can see, K can start from 1 banana per hour to maximum among the elements of the array. For example, in this particular case, it can start from 1 to maximum is 11. And he should choose a K that is very low value or the minimum possible value, and you should finish eating before the guard comes. See, there are many parameters. He can choose K and choose a minimum possible value of K such that he will eat all the bananas within the rule he has described for himself, and he will be able to finish it before the guard comes. So there are a lot of parameters. One is the number of bananas in each piles. Another, a tunable parameter for himself, he has the freedom to choose, and a rule of eating one pile at a time per hour rule, and he should finish before the guard comes. There are many parameters things. So how can he do that? One thing you can do is that you can start to check from K equal to 1 to maximum of piles, and each examples you can do a brute force search, and you can check whether the Koko was able to finish all the piles before the guard comes or not. So this is the brute force. But is there any better way? Yes, there is a better way. I'm not going to write the brute force. I have just put light on how the brute force would work. The better way is that You can choose k not like linear fashion, but you can use the concept of binary search. Like you can keep the left as 1 and right as maximum of files, and then you can do the binary search and you can check like which portion is going to satisfy or not. If it's slow if or fast, based on that you can arrange the mid and you can arrive at the optimum solution. So it's better to go back to the solution. So one more thing I would like to say, if this for example, let's take this pile. Okay, there are 7 bananas in this pile, and if suppose the speed is 3 hours, 3 bananas per hour. In that case, 7 by 3, which is equal to 2 point something. So in that case, you should round up to 3 hours, because 3 hours before elapsing 3 hours, this monkey or the Koko is not going to touch the next pile. So this rounding up to the next greatest integer is the one we are using. And in the Python thing, there you can use CEL mathematical inbuilt operator for doing it, or equivalent to CEL you can do something else also. That also we can check if required, but it's better to use this particular thing. So let's try to build upon the code. I hope you understood what are the logics and what are the parameters. There are a lot of things which you need to be aware. Okay, let's try to build up the code. This is the class definition and all. Class solution and the method inside the class. Okay, define minimum eating speed. And what are the parameters? Parameter is one is the list, which is named as piles, list of integer. Another is another integer which represents the time of break of the guard. Okay, and you should return integer. This integer is nothing but the speed at which the Koko is going to set for himself, and I am going to use a helper function. Okay, this I am commenting out for better readability. Helper function. Okay, so let's see what this helper function is doing. Define can finish. So this is nothing but a function that returns true or false based on an input or argument k. Like if you insert the speed, it will evaluate whether the Koko is able to finish all the piles or not based on the current speed. That's what this helper function do. It will return yes if it can finish. If it's returned no, that means no, it cannot finish. You should increase the speed. That's the thing it's going to tell that. Okay, so let's fix hours equals to initially it's 0. Now we need to iterate. For pile in piles, and what we are going to do, we are going to add hours plus equals CEL. So I told you this will round up to the highest integer. For example, if it's 2.5, it will round to 3. If it's even 2.1, then it will round to 3, because as we said, the Koko will wait even though it's finished early and it has surplus time. It will wait until that hour elapsed. So that's the reason why I am using CEL function. Okay, so pi by k. So for k particular speed, it will calculate all the hours, and if the hours which we calculated is less than the time of the guard's break, that is a true. In that case, it is finishing. So we need to return true or false like that. So return true if hours less than or equal to h, which is the guard speed. Okay, this is the helper function will do. Now let's go back to our real thing, and we can call the helper function whenever we need it. These are the range of k we can choose. Left comma right. Left we can choose from 1, and right we can choose up to the maximum of piles. Okay, and let's use the binary search method. Why left less than right? In that case, we are going to find the mid is equal to left bar plus right flat division by 2, and we will check now. If can finish, we are going to call the helper function. Okay, mid. If the mid can finish, okay, then what we can do? Then we need to slow down. We already, like Koko wants to eat very slowly. So slowing down, that means we need to change our right. Right is the one thing's maximum speed. So if it can finish in the middle, then check for the slower options. That's why the right will be assigned as mid. If it cannot finish, okay, then try to increase the speed. So else left equal to mid plus 1. So once this is done, we will arrive at the optimum solution. So at the end, we just need to return the optimum speed at which Koko has decided for himself. Return left. So the question is, what is the time complexity? Time complexity is pretty much simple. Since we are utilizing, there are a few things which one can see that basically if you see each options, this is calling through the piles. If the pile has n, it would have been order of n, many of n plus, and binary search itself like order of n log n. Here n log n, what is n? N is nothing but number of elements or something like that. So there are few things you can explain, like each component, how it is comes from all those things and all. But binary search, there is not n. The binary search is been decided by one particular thing, that is nothing but the range of speed it can go. So it's 1 to maximum of piles. So maximum of piles is the one thing the binary search should be interested in. So I would say this particular helper function order of n, and the binary search would be order of n log maximum of pile. So you can just write it only particular this thing. It is always better to think like each component how it's going to contribute. And the space complexity is to the order of 1. Okay, and I hope you understood this problem statement, and thank you for listening.